Now this is an interesting question. We are expected to find the area of this circle. Now you can see the circle. This is a beautiful circle with this diagram. I'm going to take this point as A. So the secant line hits the circle at these points. Okay, you have intersection here, intersection here, intersection here. Now this distance is given as 4 units. This distance is given as 3 units. This distance is given as 13 units. And from O, right, this O is the radii. So the radii is hitting the chord. Right, so this is the chord and the circle there. Right, so what I want to do is I want to apply Two Secant Theorem. I want to take this entire length. Say I'm going to take this point as B, this point as C, this point as D. So by Two Secant Theorem, we know. So what do we know? We know external segment BP multiplied with AP is equal to PC multiplied with DP. So this segment is 4 units. This entire segment, I don't know. I'm going to take this segment AB as a sum X. So this is going to be X positive 4. This segment is 3 units. So this entire segment is 3 positive 13. So this is 4 times of X positive 4 is equal to 3 times of 16. You divide by 4, you get X positive 4 is equal to 4 divided by 4 times is 12 units. So X is equal to 8 units. Now, by the chord bisector theorem, by chord bisector theorem, if I were to take this as OE bisects AB, right? So that means this distance will be same as this distance. This entire length is 8 units. So this is going to be 4 units, this is going to be 4 units. Now this is a bisector, so this angle is 90. Now I'm going to connect B with O. Okay, it's a right triangle now. So since I'm going to take this point as a sum Q, okay, since OQB is right angled, we can use Pythagoras, right? So I'm going to use what I'm going to do is use the next space here, next side of paper. So since OQB is right angled, by Pythagoras theorem we know that, what do we know? We know that OQ squared plus QB squared is equal to OB squared. Now radius I don't know, I'm taking it as R squared. So OQ squared. Okay, so this OQ is actually given. Let me write that OQ, or it's not OQ. It's yeah. Okay, let's get the data. So OQ is given to be as 3 units, right? So this is 3 squared positive, this is QB. QB is 4 units. So this is 4 squared here. So this is going to be 9 positive 16 is equal to R squared. r squared is equal to 25, so r is equal to root of 25, so r is equal to 5 units. So we have got the radius as 5 units. So therefore area of a circle is equal to pi r squared, which is nothing but pi times of 5 squared, which is 25 pi square units. Right, so what are the theorems we used here? We used the two secant theorem and chord bisector theorem to solve this question.